And we've got a great speaker. Ironically, Kenny's here to talk in front of a big haymaker. So we're going to hear a little bit about what's going on. Kenny's a senior climatologist with the Minnesota DNR. He's also adjunct assistant professor at the University of Minnesota. And Kenny, thanks for coming today.
Sure. Good to be here. And is this one okay? I think I do need both. Okay. In stereo.
This works, and there's a laser pointer on here if you need it.
Thank you. Melissa's last slide, I saw an ice cream cone. I don't know what you all saw, but so my name's Kenny Blumenfeld. I am a climate scientist with the Department of Natural Resources in the State Climatology Office. So I work physically on the St. Paul campus of the University of Minnesota. I'm a state employee, but we squat on university property. We're just I know what everyone really wants to talk about, and I think the kind of major pieces fit together here. So just kind of, I'm not sure what that little, I see. Okay, well, the deal is, we had 3 straight years of dry conditions, 2020, 21, and 22. And then that was a flipped from an extraordinarily wet 2010s and especially 2019, which was kind of the exclamation point on those wet conditions. 2019 in Minnesota was our wettest year on record on a statewide basis. 2018 had our all-time station record precipitation, which broke the record that had been set in 2016. So we were just in 2014, June was the wettest month of any month on record. It was just outstandingly wet during the 2010s. And as we know here, we then went into pretty harsh dry conditions, and that extended into 2021, where we really had high levels of drought, especially in western and northern Minnesota. And then in 2022, where the northern Minnesota dryness abated and it took off in southern Minnesota. So we still have long-term deficits in much of the state. You know, it's easy to get myopic, to start looking at just what's right in front of you and kind of forget where we've been coming from. We have, especially in southern and central Minnesota, we still have long-term deficits going back to 2020 that are on the order of 5 to 10 inches of precipitation that we're just short, even with the wet conditions that have arisen recently. Obviously, much of the growing regions in Minnesota have been very wet since November, but you need to, wintertime is wild because that's our dry season. So having a wet, dry season, you kind of have to take that with a grain of salt, but it's also this really potent period because we build so much of that water that we get during the winter on the landscape. And then, the concern is, are we going to release it all at once? And are we going to have a bad early growing season because of it? Right now, the outlooks favor kind of a wet and cool March, and then sort of normal conditions for the rest of the growing season. That's just, you have to also take those outlooks with a grain of salt. And you may have heard that La Nina is present, but it's kind of going to hand off, and we're probably going to move into an El Nino situation at the end of the growing season and into next fall. And if we have time, I'll talk a little bit about what some of the implications of that transition, because we took a closer look at the climate office here. So just to kind of recap the 2010s, especially in southern Minnesota, the precipitation departures were extraordinary in many areas. In some cases, if you look at that darker outline and all the kind of bright blues and pinks and purples that are south of that outline, these are all areas in the surplus, large surplus in many cases. And this is where it might have been 40, 50, or even up to 65 inches of additional precipitation that fell in these areas during the 2010s. Now, average annual precipitation in central Minnesota is about 30 inches. In southern Minnesota, it's a little more, 35. But so we're looking at, in some cases, nearly 2 years of additional precipitation fell during the 2010s. And, what a difference if we just look, 2019, this is our April 1 through November 12th. That's kind of when we cut off the wet season, the water season precipitation monitoring, where we were, in many cases during that kind of extended growing season, 25, 50, even 75% above what would be normally observed during that time. And that put us on the right map that you can see there in the 95th to 99th percentile. In many cases, it was just the wettest growing season on record. Versus 2020, same set of maps. Now you've got really what's a more normal precipitation pattern on the left there. We had some wet areas, some dry areas, but we really came down from where we had been in 2019 and the 2010s in general. And by and large, it was below the median for precipitation. So it was below the 50th percentile on kind of the drier end of the spectrum. Some areas were really dry, like in western Minnesota and far northern Minnesota, and other areas were just, we were starting to notice it. Get into 2021, and now those yellow areas start expanding on the left, and you start seeing more of the oranges and reds on the right, showing that now, with the really dry conditions, we ended up, for the growing season, maybe in the 15th or 25th percentile. This is also misleading because in 2021, we were really dry right up until we got into August or so. And then things got pretty wet. We were saved by the bell a little bit in the late summer and early fall. And so that's affecting some of these values. If we looked at the height of the drought, it was a different look altogether. And then, of course, in 2022, northern Minnesota totally recovered from the drought and then some. But then the southern Minnesota, kind of a belt that goes from around Marshall through Redwood Falls, Lamberton, that area, into the Twin Cities area, ended up in pretty dramatic dry regime. And in this particular case, yeah, we did get some precipitation in November, but we were really dry. We were also wet in April and the early part of May, but it was June, July, August, kind of normal in August, but September and October, it was just a very dry period. So big difference, right? We switched out of a wet regime into a drier one, and we're not positive where we're going to go, but that's the background and the backdrop for where we are. Here's what it looked like, same maps, but at the peak of the 2021 drought. So instead of covering the whole April 1 through mid-November kind of extended growing season, this takes us right into mid-August instead. And you can see huge precipitation deficits on that left map, where for that period where you would normally get, in southern Minnesota, going from April 1 to mid-August, it would be common to have 15, 20 inches of precipitation. And we were getting about half of that or less in many areas. And that put us through much of the state below the 5th percentile for precipitation. So that's why that drought was so extraordinary. It wasn't the seasonal or the annual precipitation. It was, and remember, that was a hot summer too. So not only were we not getting water, but we were evaporating the crap out of whatever water we could get. And so we were losing it left and right. And so it kind of looked like this drought map on the left. And then there's a totally dried out pond upriver from the Pelican Rapids Dam, things like that. And then in 2022, this is the Minnehaha Creek in Minneapolis, but you saw this all over southern Minnesota. Small kind of ephemeral streams that they might be a little bit flashy, but they just dried out altogether. Not something that we see normally here in Minnesota, where your streams, even when you hit a dry run in the summer, you still usually have a foot or 2 feet of water. These just completely ran out. So our soil moisture at Lamberton, which is one of the better long-term soil moisture sites in the state, and they have a good historical record in any case. The left graph's a little confusing, but you see that black trace through the middle. That's kind of what's historically normal, and it's in terms of inches. And you can see different years, and 2022 is a yellow one, and we're way below that line as we got into 2022. And on the right is the full profile. And what you can down to 60 inches, how much moisture, how much water is in that soil profile. And you can see that it's incremented out. And we honestly, because of the wet spring, we started out in pretty good shape in 2022. And then we just crashed. We hit that dry spell and we crashed, and we finished the growing season well below historical averages. And this isn't just at Lamberton. We're, I know that different soil types and all of that all over the state, but this is something we were seeing and hearing about pretty much everywhere, especially in southern Minnesota. If you add up all of the counties that were kind of in that affected region, and you take the total precipitation from June through October for that entire area, just average it over that area, this was back to 1895, the driest June through October on record. So, in our office, in the climate office, we're always asked, like, oh, was this the worst drought ever? Is this the biggest snowstorm ever? And there's always context and nuance. And no, this was obviously not the worst drought, but this was, in terms of what you think of as flash drought, a rapid onset dry spell. We had never experienced anything like this one. Mercifully, it was not hot the way that 2021 was, and that would have made it even worse. And again, the conditions only got to that third level of drought, D3, which is the second worst. It's extreme, but not exceptional. And some of that's because we had a little bit of money in the bank from the wet spring. That really staved off even worse conditions than what we experienced. Just for context, here's what those soil moisture profiles looked like in 2018 and 19. Way above and way above normal, essentially. 2015 and 16, way above normal. So we're kind of going backwards through the decade. 2014 and 13, now you could see that at the beginning of 2014 and then throughout 2013, we were below average. This is because we were actually coming out of a deep drought that began in 2011 and extended into 2012, which is the one you see on the left. And this was really bad. And farmers were not really happy this year. Although that year they were happy if they were able to get a corn crop in, because other states were hit harder. And so I actually got a pretty good price at the market, and there were a lot of new pickup trucks for the farmers that made it. All right, so looking at this year, looking at right now, going back 120 days, we've had about 4 to 8 inches of precipitation across central and southern Minnesota. The northeastern part of the states actually had the most precipitation, stretching into the eastern and northern Twin Cities metro area. But you can see eastern and southern Minnesota have, abundant precipitation. Over this 4-month period, 4-month period, you would normally expect 5.5, maybe 6 inches of precipitation. So actually 5 to 6, and that even 6 would be a bit high, because really during the winter months, December, January, February, an inch is average if you're lucky, about an inch. And then November, you get maybe 2 inches, 1.5 to 2 inches. So 4.5, 5 inches would be typical. So we're above normal, and you can see the map on the right, the deviation from normal in terms of percentages. Big part of the state's 30 to 50, or even 50 to 100% above normal. So way up there. The current snow depth. But we've got a healthy snowpack, even with the rain last week. We had strange February rain. And even with that, we've got still a fairly healthy snowpack. So 2 feet of snow or better in northeastern Minnesota. and northern Minnesota, it's about 1.5 feet currently on the ground. In central and southern Minnesota, it's anywhere from 4 inches to maybe a foot or so on the ground. Of course, that might be a little misleading because there's a lot of water in that snow. This is the map on the right. Yeah, it's probably hard to read the scale, but that's the snow water equivalent. So how much water is in the snow? And this is mostly from remotely sensed sources, although there are some attempts to measure this with instrumentation, and there are some manual observations that can help augment this. And this is all basically digitized by the National Weather Service from the National Operational Hydrologic Remote Sensing Center, which is just a beast of a name and acronym. But it is, you can see around Minnesota, there's about 1 to 3 inches, depending on where you look. Maybe in northern Minnesota, a bit more, and in southern Minnesota, a bit less. But 1 to 3 inches of water sitting on top of the ground in the snowpack right now. And when you consider that, there's nothing unusual about that. You know, in our years where we see the big flooding and nobody can get into plant, those are years where we often have 5, 6, 7 inches sitting on top of the ground. So right now, it's not a dire situation. And this is why the first kind of wave of flood outlooks from the Weather Service just said, you know, the risk is average. If we get more precipitation than would be normal and repetitively, then the risk would increase. And obviously, if we dove into deep deficits, then the risk for flooding would decrease beyond where it is now. But so historically, about average risk for flooding. And that's actually a pretty good proxy for if all things were just kind of carried out. That's a good approximation of what early growing season conditions would be like. If you're going to have a lot of river and stream flooding, you're probably going to have a lot that, think of all that water backing up into people's fields. It's before, as it's draining out, even if you've got good drainage systems in place. And so the years that have lots of river flooding tend to not be great for getting in the fields also. And so right now, you know, it's not perfect and it's not terrible. Of course, here's what people want to talk about. This is the snowfall forecast beginning now through Thursday. Of course, this could shift up or down 25, 50 miles. The numbers could move up or down by 3 to 5 inches. You know, there's no guarantee that that middle range and all the reds is going to be 17 to 23 inches. It might be 15 to 20 inches, and it might be 20 to 25 inches. There's a lot of uncertainty in the specifics, but a pretty good idea of where most of the snow is going to fall. And it's basically the southern half to 2/3 of the state. This is going to put, you know, so again, just keeping, this is not one of those cement mixer snowstorms like we had in early January or in mid-December. This will be mostly powdery type of snow. So even where you get those really high snowfall totals, it's probably only going to be about 1.5 inches precipitation. And that's at the higher end. Most of this area is going to get 3/4 of an inch to an inch, maybe a little over an inch of precipitation as snow. And then some of the more extreme areas will get, you know, over 1.25 inches. So this will add moisture to the spring melt. We talked to some hydrologists. We ran some basic numbers. So you can take the map that I just showed you and add essentially 1 inch across most of the state or much of the state. It's going to add moisture to spring melt potential, but in and of itself, this event should not and would not guarantee, for example, poor spring conditions for that early field work. In fact, because we don't know, right? We don't know what March is going to bring. We know that we're at a period now where just put the sun out, even if the temperatures are below freezing, you start melting snow. And so it's quite possible that we could lose everything we get tomorrow within 2 weeks. That's possible. I'm not saying it's likely. I'm just saying because of that, if we happen to get into a dry period or a period without big storm systems, then, this would just, some of it would go into the ground, some of it would run off, but in and of itself, having an extra inch of precipitation, given the conditions that we have currently, wouldn't be a problem. What would be a problem is if this storm is followed up within a week or so by another one that gives us a ½ inch to an inch. And then a week after that, we get another ½ inch to an inch. And now all of a sudden we're in March, there's 3, 4, 5 inches of precipitation, liquid content sitting on top of the ground. Then we'd start to have some concerns, but we're not there yet. Okay. The outlooks indicate that we're going to be wet and cool. So that would, if you translate that during March, that would be more snow, maybe some rain, but cool and wet usually means snowy in the winter time for us. And then we kind of transition into normal forecast ranges. So, you always have to be careful with the Climate Prediction Center. They have a checkered track record for sure. And we like to, we're really lucky because we just talk about mostly the climate that already happened. So we get to be right 100% of the time. And then we have these colleagues who, they get paid really well, but they have to make 60, 90-day forecasts, which are really hard to make. And then, and then everybody hates them when they're wrong and nobody compliments them when they're right. And everyone's always saying, well, why should I even do this? The Farmer's Almanac, which is the bane of every climate scientist's existence. Well, the Farmer's Almanac could do better than you. And so that's what they have to put up with. And we just like piling it on and saying, well, these guys are wrong a lot of the time too. So take it with a grain of salt. March is currently forecast to be a similar pattern to what we're in now. Generally cool and generally wet over our region. So that, I'm not positive what the physical mechanism behind that is, but they actually spend more time doing this than I do. So we'll accept it. And that's why we present their forecasts and not ours, because ours would have even less credibility. And then you'd really have something to laugh about. When we get into the early growing season, April through June, this is always frustrating. I meet with a bunch of farmers and show them these maps and they're like, this is useless. We'd rather see something on the map in Minnesota, right? Some color to tell us, okay, it's going to be something other than, and the way you interpret this is it doesn't mean it's not going to be warm or that it's not going to be cool or that it's not going to be wet or that it's not going to be dry. It could be severely any of those. What we don't know, what this really says is there's equal chances. Think of the whole temperature and precipitation historical distribution, just cut it into thirds. You got a wet third, a normal third, and a dry third. And you look at all the stuff in your magic and you say, okay, this looks like we've got a better chance of being wet or a better chance of being warm than normal. And that's actually what these maps are meant to indicate. So in the southern part of the US, indications based on current data and other years that kind of looked like this year would be better chance of being warm than normal or cool. In our region, it's just equal chances. And it's equal chances for temperature and equal chances for precipitation. So not a lot to go on. All it means is we should be happy there's no smoking gun signal. That can also be pretty scary when, oh, wow, it looks like there's a really high confidence that we're going to be hot and dry or that we're going to be really cool and really wet through the early growing season. You get people start shaking with that because they don't want to have to go into prevent plant or even think about that kind of thing. So there's a lot of good about not having distinct categorizations on these maps. When we get into the summer, now the Climate Prediction Center, this can be a little overwhelming. And honestly, this is really just the lowest category of warm weather probabilities. So It's not a high likelihood. It just means that over much of the northern and central US, it's a slightly better than equal chances of being warm. That's how you would interpret that. Means that they've got, of all the evidence that they look at, a slight majority points towards warmer than normal conditions, and that would be July through September, so the later growing season. For precipitation, still nothing. So if you kind of think about what that would mean, all right, that would mean if these forecasts verified, what it would mean is we would spend the late summer evaporating and losing more moisture through evaporation and evapotranspiration than is normal, because the temperatures would be slightly above normal and the precipitation would be normal. So all other things being equal. We don't know that though. This is also pretty far out. And when you get out here, you start losing confidence anyway. So some just basic considerations to think about. You know, we still are in that long-term precipitation deficit. And we've seen really interesting responses in soil moisture over the last couple years as we've coursed in and out of wet and then dry regimes, and then had these little kind of micro-temporal responses where we go through a really wet period and the soil just eats it all up. Or then we get a sustained wet period and that builds us some resiliency against the dry conditions. So it's kind of hard to know what having a really wet winter inside of a long-term dry regime will mean if we go back to normal. It's unclear, but I think that's probably what we want right now. We do not want to remain in the kind of wet regime that we've been in, because that'll make the early spring conditions pretty difficult. So I would say normal precipitation is kind of what we'd like for a while now, until the sun starts getting really strong, and then you might, but normal, well-timed precipitation for the next couple months would probably stave off a lot of those early growing season concerns. And the current conditions as of mid to late February actually have some benefits. We don't have, and anyone out in the fields knows this, we don't have much frost penetration right now. And we have really good evidence from last week's rain that somewhere around maybe half of it, we basically, it looks like about 5 or 10% actually ran off. I know you saw the rain pooling up on your sidewalk, but that's not where most of it went. It didn't go into those puddles. We did not actually lose a lot of water to run off. And we didn't grow the snow water equivalents by the proportion of precipitation that we got. So that means the majority went into the ground, into the soil, and into the snow. So, and we know, and this makes sense because across the state, we've struggled to exceed a foot of frost all winter long. And we've also heard lots of reports of people digging through their snow and coming up with mud. And you may have had that experience too, or maybe you've got a thin lens of frost at your place. But it's not, it's that deep, deep frost that leads to real concerns about flooding conditions, because in those cases, it prevents any water from getting into the ground. So it has to run off into the rivers and streams. So we're pretty shallow with the ice and frost currently. And again, the snow and snow water equivalent are abundant, but they're really not excessive right now. They're really just slightly above normal, and they're going to get boosted today and through Thursday, and they'll be, somewhat above normal, but not yet in the danger category, danger territory. So that's something that needs to be watched. All right, I shortened this part for you because I knew everybody would want to just think about kind of current conditions and recent conditions. But I do always tie all these things we've been talking about in with what's, and I don't know how to get this cursor thing off of my screen. Oh, thank you. So when we talk about, well, how does this fit in with larger trends with the climate? You have to remember that we're different from other parts of the world, not because we're special, but just because every place is. And we've got our own distinct geography that shapes our climate. and also shapes the way that we experience symptoms, or whatever you want to call it, as the global temperatures increase, right? So global temperatures are increasing, but you might know that that heat is not distributed evenly across the world. And as a result, the weather does not change in the same way everywhere. So things that are true in places like California, places like, you know, in India, and in areas that have really distinctly unique climates from ours, those might not be things that we observe here. And you also have to remember that, yes, Minnesota is having a response. We're going to talk about it in a moment, but we also have normal ups and downs. We've always had that variability. It's always been part of our climate, and that's always going to be part of our climate because of our geography. We're in the middle of the continent. We're halfway between the equator and the North Pole. We are the same distance from the Rockies as we are from the Atlantic Ocean, the same distance from the Rockies as we are from the Gulf of Mexico, the same distance from all of those as we are from the Arctic tundra, or at least the high Arctic prairies. So we have a lot of different weather influences, and when the wind shifts to a predominant regime from one of those regions, we get variations that are different from what we have when the wind is predominantly from one of those other regions. So we have ongoing climate trends, you know, increases in our temperature and increases in our precipitation over time, but we also have ups and downs that are part of our climate that are not necessarily proof of anything other than the fact that we've always had these ups and downs. However, when we pair an ongoing trend like warmer winters, for example, with a spike in that variability towards, you know, like a kind of a high variability moment, you can get, by pairing those two things, unusual or even unprecedented conditions. So here's what we've observed. Warmer and wetter conditions on average in general. Does not mean every year is warmer than the year before or wetter than the year before, because remember, normal variations. It's just that we tend to have more years now that are warm by historical standards and more years now that are wet by historical standards, even though, as we've seen, we still can dry out pretty well. On average, we've had shorter and warmer winters. And that, I think that's that's actually our strongest climate signal anywhere. We're actually getting as much snow or more snow, depending on where you look, than we've ever observed. But the cold during winter is less severe than on average. So think of this year, you know, it's not an impressively cold year by historical standards, even though we've had some really cold nights. It's just not historically impressive. This is a major signal that we have, and it's also projected. It's our strongest change, so it's also going to continue being our strongest change. It has a direct link to the whole mechanism, the whole absorption of greenhouse gases, or I'm sorry, the greenhouse gas absorption of escaping heat from the earth, which then helps us get warmer. It has a direct connection to that. So it's our strongest change. It has our strongest scientific link, and it's the one that's going to be leading the way into the future too. But the trend towards more precipitation, which we're especially, I mean, we see it all times a year, and this event we're looking at tomorrow and a couple of the ones we've had this winter are examples that we are getting more intense precipitation events than what would have been seasonally normal at kind of any time of year, but where we really see the big impacts are during the summers. So that's that third point. We've seen bigger downpours, more excessive rainfall events, and even in dry summers, we tend to get these types of events. And we've also had fewer cool nights and just a general warming trend in summer, even though it's not as extreme as what we've seen in the winter time. So here's our moisture going back. Minnesota is in the middle of the map at the top, if you can't see it. And this is taking 30-year averages, also known as normals, and then comparing the precipitation from each of those 30-year averages to the 20th century. So if you see kind of brownish colors, those would be where that particular 30-year period is dry. And if you see greens, blues, that kind of aqua color, those would be wet. And you see the influence of the early 20th century drought, the 1920s and 30s in there affecting things. And then you can see that during the middle of the 20th century, we mellowed out and we went into this benign climate period where things were pretty normal and pretty contained and pretty controlled. And then in the last 3 decades, we got wet, wetter, wettest, and finished, the wettest 30-year period on record with the most recent normals over much of our region. And again, that was punctuated by the 2010s being the wettest decade on record. So that's precipitation. And just to prove that this is not a uniform story everywhere in the US, try and summarize what's been happening in, say, Arizona, where it was wet and then dry and then dry and then wet and then dry. Different response altogether, right? Or look at California. So we have one story, they have another. I would be saying different things and sharing different things with you if we were all in a different part of the country. We've had more, there's your annual precipitation on the left, and on the right is the average of the largest daily precipitation event each year, kind of averaged around the state. So it's not the ultimate largest event anywhere in the state, it's just the average for the stations that have long-term records. And you could see in both cases, there's variations from year to year, but a clear trend towards larger values as we get to the more recent part of the record. So annual precipitation increasing, and to some extent, that's because we're getting larger precipitation events. Driving, that's a big driver of our precipitation. We're a thunderstorm state. We get half or more of our precipitation from thunderstorms. If we get more precipitation from a thunderstorm event, then we're going to see that proportion of rain that we get from thunderstorms is going to be a larger amount, and that's going to drive a larger total in general. We don't need that. It's funny that I just give you an after. What did it look like before? When we look at the projections, all the kind of integrated climate science that takes the world of computational numerical atmospheric dynamic models and tries to run it through a series of scenarios, we see on average probably more precipitation for the region. You got to be careful though, because that doesn't always mean wetter, right? If you're looking at a strict water budget, we could have more precipitation, but if the temperatures skyrocket, maybe we'd actually have less water around. All we know is we're going to quite likely have more precipitation in almost any scenario as we get into the future. And on the right, or one of these, the one on the left is the changes in heavy precipitation, just showing the number of days with what you might think of as very heavy precipitation. We might have 1 or 2 of those days a year now. We're going to grow those by another maybe 1.5 days as we get into the middle of the century, just meaning the kinds of changes we've already observed over the last, say, 50 years, we're probably going to see that type of changes in both annual precipitation and heavy precipitation frequency continuing into the next several decades. When we look at temperature, this is more unidirectional for the whole country, but you can see we went from cool relative to 20th century averages at the beginning of the 20th century to warm and warmest at the end, most recent part of this period, which ends in 2020. That is well, it's not a linear trend, but that is a trend, right? I mean, everybody went warm, and only a part of the kind of the sort of lower Mississippi Valley is only slightly warm compared to their historical record. Everyone else is really warm. So big warming trend, and it's been driven by, these are the total temperature changes. So we've increased our temperature by about 3 degrees Fahrenheit since the beginning of the 20th century. But that is greatest in the wintertime. and especially in northern Minnesota. So a typical night in December through February in northern Minnesota is now like 7 or so degrees warmer than it would have been at the beginning of this period. Whereas summertime days on the right there show much less warming and even, a statistically insignificant amount of cooling in parts of southern Minnesota. So we're getting warmer by a lot, and we're really getting warmer in the winter, but we're not yet showing signs of getting hotter in the summer. And what we're really doing is we're getting less cold dramatically. Typical night in International Falls in January is now, 10 degrees or so warmer than it was just 50, 60, 70 years ago. We have lost 2 to 3 weeks on average. You can see the ups and downs, but we've lost 2 to 3 weeks on average of freeze season. In other words, we've expanded that sort of potential growing season where temperatures are above freezing by 2 to 3 weeks. On the left, looking at Milan, which is the very best climate station in Minnesota. It's volunteer observer for the National Weather Service going back 3 generations, rural community. You could see if you look at the hottest days of summer, the hottest days of the year, the 15 hottest days of the year, there's really no trend. There's no evidence that the highest temperatures of summer are increasing. But when we look at the dew point record from the Twin Cities, which goes back a long time, we actually are seeing that the extremes of dew point, not every year, this is moisture. That's what you think of as humidity. They're increasing. We're seeing, and they're not exceptionally common yet. They're just more common than they used to be. So those days where it's not the heat, it's the humidity, some of those days, not all of them, but some of them are, quote, worse than they used to be. And then the last thing I'll point out with all of that is that we also have to expect surprises. Here's Portland, Oregon, 45 hottest days on record going back to the middle of the 20th century. I use Portland for 2 reasons. One is because their climatology for hot days is very similar to what we have in Western Minnesota. Look at these values. They're all, their hottest days are 102, 103, 104. Their record through 2020 had been 107 degrees Fahrenheit. That's something you'll see in central, southern, western Minnesota pretty regularly. But then the other reason I use Portland is because this is what happened there. So their hot weather climatology was similar to ours. And in 2021, in 5 consecutive days, they had 102, 103, 106, 110, and 116 degrees. So then they all of a sudden broke their all-time record 3 consecutive days, first by 1 degree, then by several more degrees, and then several more again. And if that could happen to them, where there had really previously been no sign of change at all over time, we have to be ready for that kind of thing too. There's definitely more heat in the system, making these sorts of things possible, even though Minnesota has not experienced anything like that yet. So with all that said, to summarize, our current, we're wet, right? But this wet regime since November is inside of a longer term dry period that stretches back in some cases to 2020. January of 2020 is where we really started getting the dry deficits dominating. And since then, most of Minnesota has had more dry months than wet months. The outlooks favor a cool and wet March, but there's really no signal for the early growing season. And when we get into the later growing season, as much as you want to believe those forecasts, they call for maybe slightly warm conditions, still no signal for precipitation. And then the backdrop for all of this is that over the long haul, we've been seeing a trend towards wetter and warmer conditions with shorter on average and less severe in terms of cold winters and longer growing seasons, more precipitation extremes. And these changes that I've summarized are all sort of expected to continue as long as you keep in your mind that there's going to be variations. And in particular, when you think of varying towards a really hot year, or when we get to more extreme heat, which is almost guaranteed as we get into the future, when you pair that with a dry year, we might eventually, we don't know when this would begin, but in the next 2-3 decades, it would be likely to have begun, if not sooner, start seeing levels of drought that are rivaling anything we had seen historically, and maybe even becoming unprecedented in some areas. So just because we've been getting wetter and we have these trends towards more precipitation, we can't turn our back on drought, because as Minnesota keeps getting warmer, we're going to be more vulnerable to losing water during hot conditions in the summer. And if that happens when it's dry, to be careful. All right, that's what I have. I hope everybody travels safely, and I guess I see a question here. So I'll take a question. It says we've seen more 12-inch rainfall events in the last couple of years. How much precipitation can we expect from these bigger events in the future? So that's a hard question to answer, because 12-inch precipitation events are still really, really rare. I mean, they're still in excess, even when you do the most aggressive updating of the precipitation design standards, the 100-year, the 1,000-year. These are still events that in any one part of Minnesota have a less than a 1/100% probability of occurrence. They're still very rare. You just can't predict it anywhere. However, they're increasing in frequency in their own sort of subtle way. So, and what we've seen when we look at the sort of the size of the biggest events is like they're generally growing by 5, 10, 15% over time. So what used to be a 100-year type event in the past, you could probably add up to an inch onto that, and maybe that would be a more appropriate 100-year event now, and then going 50 years forward, maybe another inch or so on top of that. And that also matches what we see from what are called attribution studies, which is when climate scientists run a bunch of models to ask a question: how much of this precipitation, how much of this extra precipitation was because of the fact that we have a much warmer climate system, which is evaporating more water into the atmosphere and making more fuel available for these systems? And it usually is in that range, 5 to 15% additional. That's what we see with tropical weather systems. It's what we see with the big Midwestern type flood situations. And it also comports with kind of the thermodynamic reality of what happens when you increase temperatures. So it increases them substantially, but maybe not in the kind of eyeball popping way that people might expect.
Do we have any questions in the room? If not, let's thank Kenny for his contribution.